everyone, and welcome back for another deep dive with us. Today we're going to be tackling something that I think you've probably heard about before, the whole left brain, right brain thing.
Yeah.
You know, like, oh, if you're logical, you're left brain, but if you're creative, then you're right brained. You know, it's kind of a myth.
Yeah, it is. It's
Well, no.
yeah.
But it's as with like a lot of myths, there is some actual science behind it.
Right.
So it's really fascinating to kind of dig into this and figure out like, okay, where did this come from?
Yeah,
And
absolutely.
why is it so popular and what's the real story?
Absolutely. Yeah, it's really interesting how this myth kind of took on a life of its own, you know.
Yeah.
But it's like you said, it is based on some real science.
Yeah, so let's unpack this. So to kind of understand where it came from, we kind of have to go back to just the very basics of the brain.
Right. Basic brain anatomy.
Yeah, brain anatomy 101.
Yeah.
So, you know, if you picture your brain kind of like a walnut, the two halves are called the hemispheres,
Right.
and they're connected by a bundle of nerve fibers called the corpus callosum.
The corpus callosum.
Right.
Yeah.
And then, you know, each hemisphere has different lobes, like the frontal lobe, parietal lobe, temporal lobe, and occipital lobe.
Right.
And they kind of specialize in different functions. And you know, initially, it was thought that the brain was perfectly symmetrical, like a mirror image on each side.
Right. Exactly. They thought that it was just, basically two of the same thing.
Yeah.
But then some interesting research started coming out in the 1800s that challenged that view.
Oh, okay.
Yeah.
So what kind of research?
So researchers like Paul Broca and Carl Wernicke were studying patients who had very specific language difficulties.
Oh, okay.
Yeah. So Broca, for example, he had a patient who could only say the word tan. That was it, tan. and after the patient passed away, Broca did an autopsy.
Okay.
And he discovered that there was damage in a particular area of the left hemisphere.
Uh-huh.
And we now know that area as Broca's area.
Oh, okay.
And it plays a really key role in speech production.
So that's how we learned about Broca's area.
That's how we learned about Broca's area.
Yeah. And so Wernicke, did he find something similar?
Wernicke did something similar, yeah. He was studying patients who could speak fluently, but what they were saying, the words they were using, were jumbled and nonsensical.
Oh, wow.
So, like, the grammar was all over the place. The words were just kind of, randomly thrown together.
Okay.
And so he also found that there was damage, and in his case, it was in a different part of the left hemisphere.
Oh, wow.
And we now know that area is Wernicke's area,
Yeah.
and it's crucial for language comprehension.
So it seems like even from the very beginning, there was this understanding that the two hemispheres weren't exactly identical twins.
That's right.
That they had these, at least when it comes to language, they had these different specializations.
Yeah, these discoveries were really groundbreaking at the time because, before that, people thought the brain was just symmetrical, two of the same.
Yeah.
But this really showed that there are these specific areas that are responsible for very specific functions.
Yeah. That's so interesting. So, okay, so we start to see this kind of specialization in the 1800s, but then things get even more interesting in the 1960s with the work of Roger Sperry and Michael Gazzaniga.
Absolutely.
Yeah.
This is where those famous split brain experiments come in.
Yeah.
And they were working with patients who had undergone a procedure called a corpus callosotomy.
Wait, a corpus callosotomy? What is that exactly?
Okay, so the corpus callosum, remember, that's the bridge between the two hemispheres?
Yeah.
Well, in this procedure, they surgically severed that connection.
Whoa.
Yeah.
They basically split the brain in two.
Essentially, yeah. And they did this to treat severe epilepsy that wasn't responding to other treatments. And what was really surprising at first is that there didn't seem to be any major side effects from this procedure.
Wait, so you're telling me that these patients had their brains basically split in two and they seemed fine?
I know, it's pretty remarkable, isn't it?
Yeah.
But of course, as Sperry and Gazzaniga started doing these experiments with these split brain patients, they started to notice some very unusual, very strange behaviors.
Oh, okay. Like what?
So, for example, they would show a patient an object in their left visual field.
Okay.
And now keep in mind that information from your left visual field is processed by the right hemisphere of your brain.
Okay. Got it.
So they would show them this object, and the patient would say, I don't see anything.
Oh, because the speaking part of the brain, that the left hemisphere didn't have the information.
Exactly.
Wow.
But here's the really cool part. If you then ask the patient to point to the object with their left hand, which is controlled by the right hemisphere,
Yeah.
they could do it perfectly.
That's amazing. So even though they couldn't say what they saw, their right hemisphere was still processing that information.
That's right.
That's incredible. And I know there was another really famous experiment involving the word heart.
Oh, yes. That's a classic one. So they flashed the word heart on a screen,
Okay.
but they flashed it so that he appeared in the left visual field and art appeared in the right visual
Oh,
field.
that was smart.
Right.
Okay.
And when they asked the patients, what did you see? They would say art.
Right, because that went to the left hemisphere.
Exactly.
Yeah.
But then when they asked the patients to point to what they saw with their left hand, they would point to each.
No way. That's like it's like they had two brains giving different answers.
It really seemed that way.
Yeah.
And it was these kinds of observations that really led Sperry to conclude that, okay, the two hemispheres do specialize in different tasks.
Oh.
The left hemisphere seemed to be the seat of language, logic, linear thinking, math, and the right hemisphere seemed to be more about visual and spatial processing, facial recognition, music, emotion, that kind of thing.
So that's where this whole idea of, left brain being logical, right brain being creative comes from.
That's right. That's where the seed of the left brain, right brain theory was planted.
But I'm guessing there's more to the story.
Oh, there's much more to the story.
Yeah.
Like we said at the beginning, this is more of a myth.
Right.
And the science, as always, is way more complicated.
I have a feeling things are about to get even more interesting.
Oh, absolutely.
So stay tuned, everyone. We'll be right back.
And we'll delve deeper into the fascinating world of the brain.
Welcome back. So before we went away, we were chatting about those split brain experiments that Roger Sperry did and like how his ideas about hemispheric specialization kind of started this whole left brain, right brain thing.
Yeah, exactly.
Yeah.
Yeah, those early studies were really, really influential.
Yeah.
But as more research was done, it started to get more complicated. Like those simple categories, left brain equals logic and right brain equals creativity.
Right.
They started to kind of fall apart.
Okay, so tell me, like, where did the cracks start to show? Like, how did those categories start to break down?
Well, remember how Sperry said the right hemisphere was good at like visual tasks and spatial stuff, but not so much when it came to math?
Right. That was part of his whole, like, left brain for logic and language thing?
Yeah, yeah. But later research showed that while the left hemisphere is dominant for certain math skills, like, complex calculations
Right.
or memorizing times tables, the right hemisphere is not completely useless when it comes to numbers.
So the right brain can't do math idea is wrong.
Well, it's an oversimplification for sure.
Okay.
Turns out the right side of the brain is actually pretty good at other types of math, like estimation
Okay.
or spatial reasoning,
Yeah.
which are really important for geometry and navigation.
Ah, that makes sense. I can see how those skills would be connected to the right hemisphere strength, like, in visual and spatial processing.
Exactly.
Yeah.
And it's not just math. Researchers have also found that the right hemisphere actually plays a pretty big role in understanding the more subtle aspects of language,
Okay.
like metaphors,
Oh, okay.
humor, sarcasm, that kind of stuff.
Interesting.
So it's not just about like understanding the literal meaning of the words, but also the emotional tone of what someone is saying.
Oh, so you're saying both sides of the brain are involved in both language and math. They just each kind of do it in a slightly different way.
That's a great way to put it. Yeah, it's not about one hemisphere being better or dominating the other. It's more about the two working together in this coordinated way.
Okay.
And this brings us to another super important concept that really challenges that left brain, right brain myth. And that is neuroplasticity.
Oh, yeah, neuroplasticity.
Yeah,
The brain's ability to adapt and change throughout our lives.
exactly.
I mean, that is a fascinating idea.
It is truly remarkable. It's like, it means that the brain is not this like fixed static thing.
Yeah.
It's constantly rewiring itself, forming new connections, strengthening old ones, even creating brand new neurons.
Yeah.
And this ability to adapt is essential for learning. It's essential for recovering from injuries and just for, dealing with life's challenges.
Yeah, it really is mind-boggling to think that our brains are like constantly changing and evolving even as adults.
Right.
And I've heard some really incredible stories about people recovering from strokes or brain injuries thanks to this very plasticity.
Yeah, absolutely. And, when we think about neuroplasticity in the context of this left brain, right brain thing,
Right.
it really throws a wrench in that whole idea of fixed predetermined traits.
Yeah.
Think about those extreme cases of children who've had an entire hemisphere removed.
Oh, wow.
Yeah, due to severe epilepsy or other conditions.
You're talking about hemispherectomy.
Yeah.
I remember reading about those cases. It's just hard to believe that someone could function normally with, like, half a brain.
It's incredible.
Hmm.
But in a lot of cases, these children do go on to live surprisingly normal lives. The remaining half of their brain adapts,
Hmm.
takes over those functions that would normally be handled by the missing hemisphere.
That is wild. I mean, it just shows that the brain is far more adaptable, far more interconnected than we tend to think.
Absolutely. And it also really undermines this whole idea of these rigid left brain and right brain categories.
Right.
Those labels just don't account for the brain's incredible ability to change and compensate.
So if those categories are kind of flawed, then what does the scientific evidence actually say about left brain, right brain differences?
Well, there was a really cool study done in 2013 at the University of Utah.
Okay.
And they looked at brain activity in over 100 people, and they did not find any evidence that anyone consistently used one hemisphere more than the other.
So like there are no left-brained or right-brained people.
Not according to this study. They basically said that skills and talents come from the complex interaction and communication between both hemispheres. It's not about one side dominating, it's about working together.
Okay. So officially myth busted.
Myth busted.
But that still leaves a big question, right? If the science doesn't support this idea, why does it still persist? Like, why do people cling to those labels?
Yeah, that's a good question, and I think there are a few reasons for that.
Yeah, I'd love to hear your thoughts on that because it seems like this myth, it's just so pervasive. It's like everywhere.
It is, it is.
It really is, like quizzes, personality assessments. You even see it in job descriptions sometimes.
Right, exactly.
So why is it so sticky? Why does this idea persist?
Well, I think part of it is that we just crave simple explanations, especially for something as complex as the brain, right?
Right.
And the left brain, right brain thing, it's a nice, neat little package.
Yeah.
A way to easily categorize ourselves and other people.
Yeah, it's like those personality tests that like sort you into one of, like 4 or 5 different types.
Exactly, yeah.
And it feels good to have that label.
Right.
Even if it's not, totally accurate.
And those quizzes, they often play into that desire, right? They give you these descriptions that sound really specific to you, even though they could apply to like almost anyone.
Right. It's like those horoscope readings that like seem so personalized, but, anyone could read it and be like, "Oh, yeah, that's me."
Exactly. Yeah, it's a psychological phenomenon. They call it the Barnum or Forer effect,
Okay.
where we're kind of wired to see patterns and meaning even when they don't really exist.
So even though the science is pretty clear, this myth still has this like hold on our imaginations.
Yeah, for sure.
But okay, but even if those rigid categories are wrong, there is still something to be said for this idea of lateralization, right? Like our hemispheres do specialize in certain tasks to a certain extent.
Oh, absolutely, yeah. And the research of Dr. Karafeder, she really highlights this. She's done some amazing work looking at how dividing those tasks between the hemispheres can actually be more efficient for the brain.
Oh, interesting. Can you give me like an example?
Yeah, so like one of her studies, they looked at how the brain processes simple phrases,
Okay.
like green book,
Green book. Okay.
or interesting book. And they found that both hemispheres contribute to, understanding these phrases,
Okay.
but in different ways.
Okay.
So the left hemisphere is focused more on that literal meaning,
Okay.
like the grammatical rules of the language.
Got it.
But the right hemisphere is more involved in like creating that mental image,
Oh, okay.
like, picturing that green book.
Interesting. So even though we have an intact corpus callosum, our hemispheres are still working kind of independently, like two little specialists collaborating.
Yeah, that's a great way to put it. And it seems like this division of labor, it's not just about efficiency. It's also about like enriching how we understand the world. So the left hemisphere helps us break things down, analyze them. But the right hemisphere is what helps us put those pieces back together and see that bigger picture.
So maybe it's not so much about left brain versus right brain, but more like left brain and right brain, like partners.
Exactly. And this whole idea of the two hemispheres working together but in different ways,
Yeah.
it leads to some really fascinating, even kind of mind-blowing theories about the evolution of consciousness itself.
Oh, wow. Okay. We're going deep. Tell me more. What kind of theories?
Okay, so back in the 70s, there was this psychologist, Julian Jaynes, and he had this really radical idea.
Right.
He basically said that ancient humans, like, up until about 3,000 years ago, might not have had this unified consciousness that we have today.
Wait, so you mean they weren't fully, like, self-aware?
Well, his idea was that their hemispheres functioned more separately than ours do now.
Okay.
And so they experienced like their own thoughts, their inner monologues as these external voices.
Oh, wow, like voices of the gods or something?
Exactly, like gods, muses, that kind of thing. It was like their inner world was projected outward.
That is a really wild idea.
It is, it is. And James argued that he called it a bicameral mind. It actually worked pretty well for like those simpler social structures back then.
Okay.
But then as societies got more complex, they needed a more, integrated kind of consciousness.
So, like, our brains basically adapted to civilization by merging those two minds into one.
Yeah, that's the theory. It's definitely sparked a lot of debate.
Yeah, I can imagine. I mean, it's a pretty big claim to make about, like, the entire history of human consciousness, but it is super thought-provoking, and it makes me wonder if this bicameral mind thing was like a stage in our development. Do we still have like remnants of it today? Like, are there times when our thoughts feel like they're coming from somewhere outside ourselves?
That's a great question. And it's something that researchers are still exploring. There's definitely evidence that our hemispheres can act somewhat independently, even with, a normal intact brain.
Okay.
Think about those times when you have like a sudden insight or inspiration.
No, like an aha moment.
Exactly, those aha moments,
Yeah.
where the answer just seems to appear out of nowhere. Some people think that those experiences could be like echoes of that more bicameral way of thinking.
Wow, that's so interesting.
And then there's another really interesting thinker, Ian McGilchrist, and he's kind of taken these ideas about hemispheric differences and applied them to modern Western culture.
Oh, okay.
And he argues that the left hemisphere, with its focus on logic analysis, breaking things down,
Right.
that it's become too dominant in our society.
Okay.
And it's led to this kind of fragmented view of the world.
So too much left brain and not enough right brain.
That's his argument. He thinks we need to find more balance between the two to really solve those complex problems that we face today.
It's an interesting perspective, and it makes you wonder if we've been focusing too much on like one way of thinking. What are we missing? What could we do if we really tapped into the full potential of both hemispheres, working in harmony?
Those are great questions. And at the end of the day, that's really what this whole deep dive has been about,
Yeah.
questioning those assumptions, exploring how complex the brain really is, and just appreciating the amazing power of this organ that makes us who we are.
It's been quite a journey. We started out debunking a myth, but we ended up talking about the evolution of consciousness and like what it means to be human.
And that's the beauty of science, right? It's
Mhm.
always about discovering, questioning, and learning new things.
Absolutely. So to everyone listening out there, remember, don't let those simplistic labels limit you.
Yeah.
Embrace that beautiful complexity of your own brain. Challenge those old assumptions. And never stop exploring the wonders of your own mind.
And who knows what we'll discover as we keep unraveling those mysteries of the brain.